What the heck?
Tagon.
Hey, it's another math puzzle for you. Whoops. Hey, it's another math puzzle for you. The question is, if we have a large circle of radius 1 and a smaller circle inscribed, or not inscribed, but inside that big circle with radius r, and a square with side lengths s, essentially so that the square is tucked up into these two corners and it's tangent to the circle, and the circle is tangent to the circumference of the larger circle. And this is aligned precisely at the midpoint of the side of the square. What would the radius of the smaller circle have to be for the areas of these two shapes to be the same? That's the question. So, because we have r and s, we have a system of we're going to need a system of two equations to be able to solve for both of them, but the first one is pretty obvious what it should be. Because we want their areas to be the same, we know that the first equation better be that the area of the circle is equal to the area of the square. In other words, pi r squared is equal to s squared. There's our first formula that we need to solve this problem. Pi r squared equals s squared. And then it may be a little tricky to see what we need to do next, because we need two equations to solve for two unknowns. But the obvious answer, once it's told to you, at least it took me about 5 minutes to figure out what I should do, is simply to just calculate the diameter of the circle. And you can put it in terms of r and s. Since the radius of the big circle is 1, then the diameter must be 2. And you'll notice that we have 2r, right? Because it's the circle, 2r. And then we have the length s. But then what's this little tiny bit up here? So it's not too hard to figure out what that would be. Somewhere, whether it's in the circle or the square, it doesn't really matter, there is the center of the circle. It doesn't really matter where it is. Because if we go out from that center of the circle to the point on the corner of the square, that must be length 1. Right? Because it's, it's a circle of radius 1. So this is length 1, this is s over 2. Right? The distance from the corner to the midpoint of the square is s over 2, which means that this length here, using the Pythagorean theorem, so I guess I should give them names. So this is the center of the circle, I'll call it O for origin. This is A, this is B, and this is C. Okay? So we know that OA is 1, and AB is s over 2, which means that OB is simply, using the Pythagorean theorem, equal to the square root of 1 minus s squared over 4. That is OB. But we don't want OB, because we already have all of OB inside of S, right? The distance between the midpoints of the sides of the square. What we really want is this little overhang up here inside this section of the circle. And that simply means we're just going to need to subtract the length that we've just calculated from the entire radius 1. So what we really want is BC, not OB. So that tells us that BC is equal to 1 minus OB. In other words, it's equal to 1 minus the square root of 1 minus s to the s squared over 4. Right? And so this is the last thing that we need to tack on to the end of this here. So 1 minus the square root of the quantity 1 minus s squared over 4. So we end up with plus 1 minus the square root of 1 minus s squared over 4. First of all, we just need to get rid of all of the square roots. We sort of just want to get r on its own. The only way to get r on its own is to sort of replace the s's with r's, right? Because we already could write s in terms of r by simply taking the square root of both sides. But let's see if we can be maybe a little more clever about it, because the math does get a little bit hairy. So we know that we have 2 equals 2r plus s plus 1 minus the square root of 1 minus s squared over 4. Right away we can subtract 1 from both sides, because we simply don't need the number there if we don't, if it's not really there. And what we're going to do is we are going to move all of this to one side and then square both sides. So what we end up with is, moving this over to there, we get the square root of 1 minus s squared over 4 is equal to 2r plus s minus 1. Right? And we square both sides, and we get 1 minus s squared over 4 is equal to 2r plus s minus 1 all squared. Right? And then we can multiply both sides by 4. But we may as well just start replacing s now. So we know that s is equal to plus or minus r root pi, because theoretically, we could end up with a circle where the radius closes to 0 and then opens up outside of the circle, in which case you could call that a negative radius. And of course, eventually the square would get really big as well, and they would equal each other in size. I don't actually know that that would physically work, simply because the square maximally gets to here, right? This would be the maximum of the distance between the top corners of the square, and then it would start shrinking again. So I don't actually know if the second solution would physically work. You know, I get that you could have the negative circle, and then the square is maybe the same size, but I don't actually know if the square ever reaches the same size. Perhaps it does. Feel free to calculate that, whoever wants to do that. So what we're going to do is we're going to replace s squared with pi r squared. So this tells us that we can just do this. We can just replace this with pi r squared, right? And we can replace s with r times the square root of pi, because that's what it is. And we're just going to take the positive answer. And now we're going to rewrite this thing inside here. So we're going to rewrite this as r times 2 plus root pi minus 1 all squared. So all I'm going to do is just FOIL this side out now. So we end up with 1 minus pi r squared over 4 equals r squared times the quantity 2 plus the square root of pi squared minus 2 times r times 2 plus the square root of pi plus 1. Now, of course, the 1's cancel on both sides. I can then add the pi r squared over to the other side, and I get the nice simple equation. It seems complicated, but it's really quite simple. R squared times 2 plus the square root of pi squared plus pi over 4, because I just added that over to the other side, minus 2r times 2 plus the square root of pi equals 0, since the 1's canceled and I added that over to the other side. Now, of course, r equals 0 is a solution to this, but it's not a solution to the physical situation. Because if r is 0, then that means we've like zoomed all the way down to here, in which case the square has its side lengths like outside of the circle, and it would be pretty strange looking. And it wouldn't work because the area of the square would be positive, whereas the area of the circle would be 0, and so the equation actually wouldn't be satisfied. Both of them wouldn't be satisfied. And that probably has something to do with losing information by plugging in r root pi instead of including both solutions. I'm not exactly sure. But the point is, the solution r equals 0 we don't need to consider. So we just need to, we can pretty much get rid of that factor of r, even though, you know, that means we're technically dividing by 0, but it's a solution that doesn't really work anyway. So let's just add these things over and see if we can simplify this expression. So r equals this divided by this. So we get r equals 2 times 2 plus the square root of pi over this. So we get 2 plus root pi squared plus pi over 4. Now we can multiply the top and bottom by 4. And we get 8 plus 2 root pi divided by 4 times 2 root pi squared plus pi. And now I don't know how much you could simplify this expression anymore, but I think that's a format that I'm willing to accept. And that's 8 times the quantity 2 plus root pi divided by 4 times the quantity 2 plus root pi squared plus pi. That is the radius of that circle. If the circle and the square inscribed together in the larger circle of radius 1 are equal, if the areas are equal. There aren't really any nicer forms than this, because this adding the pi in the denominator sort of ruins any chances of canceling. But just to give you some perspective on how big that is, that's a radius of about just over half, 0.50243 ... So that's about as long as the radius is. So that would be right around halfway through to the center, so just a little bit more than halfway. So I hope that was an interesting question for people to see. I'm going to, one of my little geometry problems that I've come up with is going to be appearing in a very, very fun certain calendar next month. So I hope you all will look forward to that and the rest of those wonderful 31 videos that we can expect. Okay, cool, thanks for watching. Get the f*** out. Bye-bye.